Stat students, we're going to talk about how to sign up for DeltaMath so you can complete the most recent assignment. My goal in the future is actually to use DeltaMath quite a bit more to do assignments. The ones that I've been giving with the worksheets, we'll still do a few of those, but DeltaMath is going to be able to tell you if you get a question right or wrong pretty much immediately. So this video is meant to help you get signed up. Several of you probably already have used DeltaMath. If you've ever had Coach Hammond, he's used it before. Various teachers have, more last year than this year. So if you had different teachers for iMath 3, you probably ended up using it in some capacity. So if you don't have an account, you can create one, but everybody needs to go to www.deltamath.com. You can Google it, but this is the screen you get to. You can also do this on your phone. So if you're watching this video on your phone, you can also have DeltaMath on your phone and work all the problems as well. It's pretty nice and accessible through all devices. So if you need to create an account, you'll start there, top right, create an account. And I think on the mobile, it's just 3 lines, but just find create account student. And here's the first thing that you're going to need. You're going to need my teacher access code. So my access code is 211073. And I have put it on the screen in red so that during this video, if you need it for some reason. So 211073. Now, as you're signing up, you'll select the period. Now, you're either an AP student, that's my 3rd period, you're in my 3rd or 7th dual credit class. So make sure you confirm with Skyward or with me to say, hey, what period am I in again? I can let you know, okay? So make sure you pick the correct class. If you mess that up, it's not the end of the world. I can just move you into the other class. But sign in. I would recommend using your school email and password. If you want to use a personal email, that's fine, but use your, I would recommend using your school email, okay? But what if you already have an account and you need to join my class, okay? So this is a second account that I've created that's a student account. If you are a student, up at the top right, you'll see, let me see if I'll zoom in a little bit. And let me move my teacher code down. Oh, there we go. Okay. You'll see tools. You click tools, manage login and courses is the next one that you want. Okay, so manage login and courses. Here you can add a teacher or access code. And this is where you're gonna type that 211073. And it says I already have a teacher with this code, so I can change my class. If you join the wrong one, you can go here and change the classes, okay? So I could have multiple of these sections. I don't want you to do that. I want you to make sure you pick the correct class, okay? So let's say that I'll choose 3rd period dual credit. All right, so I'm in there. Once you're in the class, all you have to do is hit this DeltaMath button and it shows you the assignment right here. This could be on your phone or this could be on your laptop computer. So here's all the problems that we're going to be working. So this video was to introduce how to sign up for DeltaMath. If you have any questions about that, then feel free to ask. But we're going to go ahead and also work a couple examples and just show you what this would look like. So we've been working with these binomial distributions, binomial probabilities, and right now you're able to answer sort of the first half of this. I'm still not done adding problems in here. These geometric probabilities, that's gonna be the next lesson we do, and I've still got to add a few more in here. But let's go ahead and look at these binomial probabilities. So what's nice about DeltaMath is you all are getting your own unique question set. So you're not gonna be able to ask, somebody in the class, hey, what'd you get for number 1? It doesn't work like that. Your starting question is completely different from everyone else's, and they randomize the numbers within them, okay? There's a help video. If you want to watch the help video, the person who's created DeltaMath makes these videos. However, he's going to be doing it in a more complicated way, I think, than what I'm going to describe. So I would rather you refer to this video than his videos. If you give up, it's going to count against you, but it will show you the correct solution at the end if you have an issue with it. So rounding is something you have to pay attention to here. And you'll notice this formula is something different than what we've studied. This one here is actually we've seen this, so let me pull that up. So these are the formulas that we used in our notes. So number of arrangements times p to the k times 1 minus p to the n minus k. That's what this is actually showing here, except r is going to be the number. They have theirs different. So this is number of arrangements, number of combinations right here, and it's just a different format that I'm not using. So it says to memorize this, but we don't really need that. It's fine. Okay. Let me show you how you should work a question like this. Let me, so if I have this one here, okay, grab your calculator. We're gonna grab our calculator. I'm gonna move this over here. And this could be I could have this on my phone, the left side on my phone or on my computer, and then I have my calculator in hand as I'm working these. And these go pretty quick. So this is a binomial probability exact. And we talked about that in the notes. And we said that is the binomial PDF is the exact. Make that bigger. PDF is exact. And CDF is the range. So we're going to work one example here. So it says if a fair coin is tossed 3 times, what is the probability to the nearest thousandth of getting exactly 1 heads? So let me, I want to actually draw on this to explain what you should be doing, because in the calculator, when you press menu 5 and you go down to binomial PDF, it's going to ask you for 3 things: number of trials, probability of success, and then it wants to know X value, which is going to be number of successes you want. Okay, so let's analyze this. So it says fair coin is tossed 3 times. That's the number of trials, right? What is the probability to the nearest thousandth of getting exactly 1 heads? This is the number of successes. We want X to be 1, right? Now, what's the probability for this problem? It doesn't actually state it in here, but it's assumed that we know what the probability of getting heads is. And this is just like our notes example. Well, it's 0.5. Okay? This is all we need. This is all we need. We go back to our calculator. Number of trials, we said 3. Probability of success, well, that's 1/2, 0.5. How many successes do we want? 1. And we get our answer over here on the right side. It is 0.375. It wants to the nearest thousandth. So in DeltaMath, where did that go? Oh, it's right here. In DeltaMath, I'm going to put 0.375. Hit enter, and it tells you if you got it right or not. Okay, good. And then you go to the next one. You have 8 problems like this, and you've got all kinds of different scenarios that you're going to be using. So I'll work this one really quick. It says Mr. and Mrs. Duran have a genetic history such that the probability of a child being born to them with a certain trait is 5/9. If they have 5 children, what is the probability that exactly 2 of their children will have that trait? Round your answer to the nearest thousandth. So this is a binomial distribution, menu 5, and you're going to go find binomial PDF. How many trials are there? Well, that's how many children they have. There's 5 children. Probability of success, well, it's 5 out of 9 of them. Success would be them getting this trait. We're going to call it success even if it's a bad trait or a good trait. It doesn't matter. That's our defined success. And then the X value, how many? We're trying to find how many are going to have that trait. Well, they want to know exactly 2. So we put that in there, and I get 0.2709. We will round this up to 271. I think you don't have to put the 0 in there. No, you don't have to. That's how you'll be doing those. Let's look at the probabilities for at most, at least. This is when we do the CDF. So go ahead, have that ready. Binomial CDF. And you see this here. We need number of trials, probability of success, lower and upper boundaries. So we have another genetic history question. There's a probability that they're going to get a trait at 7/8. If they have 4 children, what's the probability that at most 2 of their 4 children will have that trait? Okay, so at most. So it means that amount or less. So we go in, we're going to type this in, number of trials. They want to have 4 children this time, not 5. What's the probability they get the trait? Well, it's 7 out of 8. And it says at most 2 of their 4 children will have the trait. So we have this idea, this lower boundary, upper boundary, and we know the most that they want at most is 2. So what's the lower boundary? Well, that means 0, right? Because none of them could have it. So this would be the correct sequence to type in here. We hit OK. I don't know what happened here. Hold on, menu, try again. Binomial Cdf. We'll try again. 4, 7/8, 0, and 2. There we go. We round to the nearest thousandth, so this is 0.079. There we go. 8 questions like that. Next, we have binomial mean and standard deviation questions. So here you're just using the formulas for binomial mean, binomial standard deviation. There they are. So you're seeing what it's asking. Binomial mean is pretty straightforward. It's n times p. So set number of trials times the probability of success. And then sigma is, the standard deviation of x is this formula here. N times p times 1 minus p, square root all of that. So that's going to be for those questions. Should be pretty straightforward. If you're having any issues, let me know, and I can help you out. Okay. And then I'll let you know when you can do, well, you'll know after the lesson, the next lesson we get, when you can do these geometric ones. We haven't introduced that yet. So I'll stop this video.